Okay, so I've just gone ahead. We're going to do it at the 15-minute mark. It's about 10 minutes early. I'm just going to post the live stream onto YouTube now, and then once that, I'll just get a channel here. Just going to share, copy, and then we should put that over on LinkedIn. On this video, streaming the webinar.
All right, mine is updated. Join the live Q&A. Boom.
Okay. Actually, we got Carlo on the line here now. Hi, Carlo. Nice to meet you. We've got David Crombie. Oh, we've got a whole bunch of people here. This is great. Hello, everyone. Welcome to the webinar. If you have any questions, just text them into the panel over to your right, and we'll be happy to answer any questions that you might have. The YouTube channel is live. We're now broadcasting this webinar on our live stream. We're also broadcasting the tour of the Garrison Woods pilot location. So if you want to just take a quick dive into that video so you can see the tour of Garrison Woods, and then pop back here for any Q&A, any questions you might have. Bring coffee, have some coffee. It's casual Friday.
Coffee is always good.
And for those of you just joining in, Eric's not wearing any pants.
Hey, you aren't supposed to tell them that.
It's live, buddy. It's live. There's no back button.
Blowing my cover. I'm just staying here up. And we also have a bet going.
Yes, we do have a bet. Do you want to tell them about the bet, Eric?
Yeah, so maybe before I do, you just tell me how many people are on the line right now.
All right. Okay. So right now, there are a total of 16 people attending the webinar, but are we including the number of people on the live YouTube channel as well? Because that you got to count that as well, I think. I think that's only fair.
Okay, but there's no risk of double dipping here?
No. Now, there's four. I just saw it go up by one. So we have 4 people on the live stream.
Okay.
And we have 16 people on our webinar right now.
All right, so call it 20.
Okay.
The marker in the sand is 100 people, and I'm buying Jason lunch. And if we're under, he's buying me lunch.
Going to McDonald's.
Nick, are they still open?
I don't know.
Are they just doing drive-through?
I think so. Probably drive-through. Yeah.
Okay. And then if we hit 1,000 people tuning into this, I will eat a bar of soap.
The charcoal one, you have that one. You can't eat the avocado.
Well, charcoal whitens your teeth, so it's probably the best.
Sure. Yeah, makes sense.
Definitely. Excellent. Well, for everyone who is in this session, the streaming of the tour is also happening right now, so feel free to pop back and forth. If you do have any questions, that's what this is for. This is for us to answer your questions about this technology, and let's take it from the top. So fire away.
Great. So I guess probably what we'll start with is talk a little bit about the history of CleanO2, where we got started. We got Kathy on the line with us as well. So back in 2005, we were sort of wondering what the future of the HVAC industry looked like, specifically what the heating industry looked like. And there was a lot of discussions that were going on around concerns over climate change and carbon emissions, and there were discussions about how we could address carbon emissions. But most of the topics that were brought up in various news channels had to do with the transportation industry and the energy sector. There really wasn't much discussion about the reduction of greenhouse gas emissions from these aggregated sources, specifically the heating industry. So I asked a few folks in the manufacturing sector that were making boilers and heating appliances of what did the industry look like over the next 5 or 10 years, and it seemed like the only clear answer I could get from anybody was just maximizing the efficiencies associated with the appliances. I couldn't get much of a clear answer in terms of what we were doing with the carbon emissions. So Kathy and I sort of set about of developing the technology to be able to directly address the carbon emissions by creating some technology that could have a meaningful impact and be sort of a standalone business that didn't require heavy subsidy in order to work. So, 15 years later, we have finally launched this technology that can have a positive impact on reducing your energy expenditures through heat recovery. We can directly capture the carbon, and by converting it into products that can be used, such as our soaps and detergents. And we're also providing some needed service capacities to these mechanic rooms by providing a set of eyes and some maintenance in there to make sure that, quite frankly, the most important part of your building is running. I mean, people generally tend to glaze over and not pay attention to their mechanic room. They're generally, reactive rather than proactive. They don't call in a plumber or a heating technician until something breaks. So,
Right.
We're providing that service at no charge to the customer as part of our mandate of keeping those systems running properly, so that you can get a head start on any issues that may be developing in your mechanic room.
Mm-hmm. So when I first heard of CleanO2, it's probably 3 or 4 years ago, and you were focusing on the residential market. Is that right?
We were, it was maybe a little bit longer than that, but it's around that time, I guess. We realized that, as a startup company with limited resources, we need to focus on the low-hanging fruit. One of the issues that we had to overcome with this notion of creating a byproduct associated with our technology is, how do you collect it? And our systems were originally designed to be inside the house. So imagine me knocking on your door every 2 weeks. Now, to some of you, that might be a plus, like, my family. However, to most of you, you don't want somebody coming by every 2 weeks to go into your basement to do a collection run on the potash that you're producing. So that sort of posed a lot of issues in terms of how do we address that. So then we switched away from the residential space into the commercial space, because you already have people going into these mechanic rooms as needed. In some cases, we work with them and complement the services that are already being provided. There's the space to be able to install our equipment. The access is there. Everything you need is there, and the price point is pretty fair in the commercial sense. So it just worked out. So we didn't abandon residential carbon capture. We just shelved it for now. We think we're going to come back with maybe a pilot project with perhaps Atco Gas, who we're partnered with, who've been huge supporters of our technology here in Alberta, as well as Fortis BC in British Columbia with our project in Vancouver and Victoria and surrounding areas. Centerpoint Energy in Minneapolis, who've got a project started down there, and we're really trying to work hard at finding a way to get out to Ontario, the Ontario market and Quebec market with Enbridge and Gasnet and other industry players that have expressed interest in trying our technology. So there's certainly a lot of opportunities here.
Beautiful. So when you were first tinkering, what did the early days look like? Was this just in your basement, or like how did your brain come up with this concept?
Well, I don't get out much. I spent a lot of time in mechanical rooms, and as Kathy will attest to, some of the earlier apparatus, I think she compared some of the apparatus that looked like something that came out of a Ghostbusters movie. It was pretty sketchy stuff. But so originally we were exploring opportunities in ionic exchange processes, where we would dilute the CO2 component into deionized water, and then we'd run it through a resin bead, and that resin bead would then bind itself to the carbon ion, and then and then somehow we would flush it down the drain, or we would we would find some way to dispose it. But it was really clunky. The capture ratio was really low. We just couldn't quite make it work. And then I was reading an article that was put out, I think it was in the Calgary Herald, I think, through a professor at the University of Calgary, Dr. David Keith, and some students had come up with this ambient air scrubber. And I noticed that they had mentioned that they were using sodium hydroxide as a means of capturing the CO2. And I thought, well, that's interesting, because we use sodium hydroxide in the heating industry as a means of neutralizing acid. So when we're cleaning boilers, we take them apart and we take the heat exchanger. Obviously, just like your kettle, right? Over time, you get mineral deposits that build up inside your kettle, right? So what do you do to clean it out? You put some vinegar in it, or you put an acid, or you put something in it to clean it out. You rinse it out, and away you go. Well, boiler's no different, right? So imagine a commercial boiler that's gone on for 5 years. You have to treat the water. So what we'll do to clean out that scale is we'll run an acid through it, and then to neutralize it, we'll put in a base. So in this case, sodium hydroxide. So we had some on hand, and I happen to have some in my basement. So this apparatus that we had built for the residential market space had a little solvent tank in it that would spray the water inside a heat exchanger, and then that's what we would use to interface with the CO2 emissions from a condensing furnace. So I put some in this apparatus, and we had it all connected to my computer, so I could actually graph the CO2 concentrations. And the moment we put it in there and I lit it up, there was this huge dip in the amount of CO2 that was being emitted to atmosphere, and there was a spike from the exothermic heat that was being generated. It was like a eureka moment. In fact, I think I danced. I actually was dancing in my basement because I was so excited, because it seemed like we'd come up with this epiphany. And
how long ago was that?
Oh, that's got to be, geez, I want to say like 8 or 10 years ago, maybe, when we did that. It was a while ago. Yeah, it was close. Maybe more like 8 years ago, I think.
Yeah. So you've been at this for a very long time. What keeps you swinging like that? To me, most folks, after a couple years, everybody wants things instantly, not realizing that a lot of entrepreneurship is trench warfare. You gain a mile and then you're back to, and then you gain, and that's just the games. What kept your fuel? What was your fuel that kept you going?
I was acknowledging that the problem hasn't been resolved. I think if somewhere along that 15-mile mark, halfway through, somebody somewhere had come up with a viable solution that had been able to move the dial, I wouldn't necessarily have accepted defeat, but I certainly would have acknowledged the fact that somebody else recognized the same value here. Nobody seems to have really entered into the market space, at least up until recently. There's a couple of organizations in the States that are doing some really interesting work, not necessarily tied to the HVAC industry, but I think Ben Lamb from Hypergiant came up with an HVAC application through algae scrubbing. A really slick looking unit. They've certainly dialed in the aesthetics. I'm curious to learn more about that. But and then there's some open source CO2 capture hardware folks down in California and around North America that are working on an open source ambient air capture technology. I applaud that work. So there's people that are getting into this smaller scale carbon capture, and I think it's a great move. But clearly we were early adopters, early beginners, I guess, for a micro scale carbon capture. I noticed a question here from Vigor Innovations. Is this CSA or approved by the AHJ? So we have CSA and UL listings on our appliances as an electrically operated appliance, and it has been approved by a couple of agencies to install in applications. But there's more regulatory work that needs to be performed on our equipment in terms of working with various categories of gas-fired appliances. So to answer your question, I don't know if it's approved by AHJ, I'm not actually sure who AHJ is. Does anybody know who AHJ? I'm not familiar with that
Neither.
organization. Bigger, if you're on the line, if you wouldn't mind just piping in who AHJ is. I'm not really sure. Oh, authority having jurisdiction. Right. Okay. Thank you. Thank you for that. I was thinking Alberta Health Services. No, that would be
Alberta
that's not
heating
Alberta
jobs.
something. Yeah, hating people.
Sure.
Jury, something. Yeah. Anyways, yes, we have authorization from some agencies that are permitting the installation of our equipment. But it's, it's slow. It's right now it's on a per site basis, but we are working at making it so that it's more widely adopted. It's new tech, so that, obviously there's going to be some hiccups that we have to get over. Thanks for clearing that up, James. Appreciate that.
And it is new technology, but you have a pretty decent install base for being a startup. Maybe talk a little bit about your first install and then how many are out there.
Sure. So the very first unit that went in was the one in the video at the Garrison Woods, and that was a prototype that went in. Funny story. I don't know if any of the folks from the original tour, from the delegates that came over from Europe, were here. That was about a little over 2 years ago. But when we got the request from John Winterborn, the Canadian Trade Commissioner to Norway, he said, "Hey, we hear that you're doing a project. We'd love to come see, the work that you're doing." And we had some early stage designs, and we were talking about putting it in, but it wasn't quite ready yet. So when they asked if we could have something for them, at the time we said yes, but we didn't have anything at that time. We just had CAD drawings, and we were staged to go in. So we rushed out when they said that they were going to arrive. We rushed out. We put the CAD model together. We worked with local manufacturers to build this first prototype, and we put it in the mechanical room. And it was a little dicey. Some of the CAD drawings weren't. The tolerances were a little off. It was still open on the back. It was really, really rough. The funny thing is, when we were expecting this delegation to show up, we were expecting maybe 5-6 people, and it was like 50 people.
Really?
40 people. There was a lot of people that showed up. And that's part of the reason why we're doing this webinar today, is because they actually wanted to come back again for April 1st, but given our current circumstances, that was obviously canceled and that was obviously a very wise move. So hopefully they're on board here with us today. Some of them watching this video, or perhaps they'll tune in later. I know they're in a different time zone. So, but that was the first unit that went in, and then just February of last year, we replaced it with a commercial unit, an updated and much improved unit compared to what was in there. And now we're also rolling out with updated units, the version. So the first unit that went out, the commercial sort of scope prototype, was a version 3, and then we went through different iterations, and now we're on the 3.3, and the units that we're shipping out to both BC and well as our partners in Minneapolis are the version 3.3s.
Great. Very cool. So everyone who's on the line, if you do have a question, just type them into the question box. There's a little chat icon. Click on that, submit your questions, and we'll get through them. We're also monitoring YouTube as well. So if you have any questions, feel free to throw them over. We have Jason Cardiff, the CEO of CleanO2, with us to answer all these questions. And all I'm going to do is dance around. So Jason, maybe you could describe to us the biggest technological barrier that you had to overcome in order to get this rocking.
I would say that a lot of it has to do with the regulatory concerns. Obviously, they're justified. We're operating with gas-fired heating appliances, so we want to make sure that we're keeping these mechanical rooms safe. We're making sure that these systems that are in operation are not being impacted negatively by our operations. So, all the regulatory concerns that we have to go through with the various agencies take time. It takes a while to get everybody on board with what we're trying to do. But once that begins, and once people understand what we're trying to do, then things tend to move forward very quickly. And because it's a hardware component, adoption for hardware is obviously significantly more complicated than softwares. For say, your software doesn't work, you try it, and then you move on. Whereas hardware, it's a little bit more clunky. Obviously, in some people's minds, there's a little bit more risk associated with a new hardware startup as opposed to a software startup.
Right.
So yeah, I would say regulatory and adoption are probably the two hurdles that we're overcoming. But we're doing a good job. We've had some real positive stories to come out of the units that are in operation. And I just noticed another question here from Vigor Innovations. Estimated cost for the units, we're selling them at $20,000 US plus the cost of install, and the return on the investment to the customer is 5 years or less. So our profit sharing model, depending on how often those appliances are running, can be at least, at the most is 5 years, but we can probably get that in 4, maybe even 3 years, depending on the certain application. Commercial tower. So the units are about the size of 2 refrigerators stacked back to back. And if you can imagine, a typical residential refrigerator, and then put 2 of them sort of back to back, that's roughly a good size. The measurements are 32 inches by 76 inches deep by about 74 inches tall, in that range. So there are some issues associated with placing the units. In some cases, some mechanical rooms are tight, but in most of them, I'd say probably 75% of the mechanical rooms that we looked at, there's room for these systems to be installed. Well, that's quite another question here. The boiler should be within 20 feet of the install. We want to keep it fairly close, just from a heat recovery standpoint. We want to try to add as much value back into the building from that waste heat. And if we're too far away, then some of that heat is dissipated, and then there may be some other issues associated with that. So 20 feet is kind of the ballpark that we look for, plus or minus a foot or two.
Sure. And what would you say is an ideal location or facility that is a good fit for the technology as it stands?
So far, it looks like aggregated residential applications, so condos and townhomes, are really good, just because they have a high demand for hot water use. So when municipal water comes into your building, it's generally coming in at around the 7 to 10 degrees Celsius mark. So then you plug it into your hot water tank and you get it up to 60 to 80 degrees. So what we do is we interrupt a portion of that water and use the waste heat from our appliances to increase that water temperature up to 15 to 20 degrees, so that your tanks aren't having to work quite as hard. So any place where there's a large amount of domestic water use, or where we're dealing with having to offset the temperatures associated with the municipal water temperatures coming in quite cold, where you have to warm them up, we can help with that.
Very cool. We've got another question. Is hotels a good market for this?
Yeah, absolutely. We do have a hotel that we're working with down in the U.S. I don't know if I'm allowed to say who, so I'll just keep my lips sealed unless I see a comment coming up there from somebody in the feed here that's allowing me to say anything. But we do have a large hotel chain in the U.S. that is working with us to be able to install one of these units. So it's a perfect fit.
Big time. And how cool would it be for a hotel to replace the soap in their rooms with soap that they're making from their own emissions?
Exactly. It's a nice circular economy, right? You take that waste stream of CO2, convert it into a chemical that's used in the soap and detergent industry. You turn it into soap, and then turn it right back into that building. So those little bars of soap and the shampoo and everything else can be made from recycled carbon. I think it's a great story. Wonderful option.
Awesome. Beautiful.
And a great impact.
Vigor is asking if he could get a spec sheet on this. Absolutely. Just put your email in the chat box, just like Vigor did, and we will go through all of it. Send everybody the spec sheets, all the details, so you can have all the information on how this thing actually works.
Should also mention too that we're happy to announce that we have a new website. We just launched it yesterday. It's live now. It's a complete redesign. You'll notice our logo is different. Our labels for our products are different. We work very closely with Mick Canfy from Energous Ventures in Montreal, who's done a tremendous job at rebranding our company. So we're very, very proud of what he's done and happy to share that with you. So if you have a moment, head on over to CleanO2.ca and check out the awesome new website.
Excellent. Awesome. So we got a couple more folks that would love to get the spec sheet sent their way. We can absolutely do that. Jason, is there a specific boiler size that you look for in order, just given you've got one size right now of Carbonix unit, is there a specific range that is a good fit?
Yeah, so from a BTU load perspective, we generally want to focus in those ranges between 240,000 BTU input and 1.5 million BTUs. And for those of you that are not in the HVAC industry, I'm trying to think of so like a commercial hot water tank or a medium-sized boiler. So if you've got like the Garrison Woods condo, I think it's I want to say 100-unit condo, and they've got about a 750,000 BTU boiler in there. So that's kind of a range of places that we look at. We can go a little bit smaller and we can go a lot bigger with this technology. We're just focused largely in that range just because that's kind of the sweet spot for us.
Mm-hmm. Cool. Angelica is asking, are there any home builders or commercial builders working with you?
Yeah, so, well, we are in conversations with Modern Niagara. We have had a few conversations with them. Eric represents Tundra Process Solutions. So we are working with Tundra. They are the distributor of our CleanO2 products here in Canada. We haven't approached anybody in the US yet, although we are beginning operations with Centerpoint Energy. So that's about all that we have.
Great. Would you be able to talk about the actual chemical process itself, like what's actually happening to sequester carbon, and how does that end up as soap? Can you explain that?
Sure. Yeah, absolutely. So we start with a dry chemical and we finish with a dry chemical. And the reason why we keep it dry or anhydrous is for safety. We're dealing with caustic material. If it was liquid and you poured it on the floor, or you poured it on your skin or your clothes, it would do some damage. Whereas in the case of where it's dry, that risk is greatly reduced. You still have to respect it. You still have to wear appropriate gear. But if you spill some on the floor, you vacuum it up or you put it in a dustbin, but depending on how much you're spilling around you. But it's a lot more safe to handle than aqueous or liquid chemical. So we put in a flake potassium hydroxide into our unit. It comes in a 25 kilogram bag. During a loading process, we'll put in anywhere from 3 to 6 bags per load, and then we close the unit up, and then we bring in the carbon dioxide emissions from the heating appliance, and that CO2 then is absorbed by the potassium hydroxide. So you have the KOH, or the potassium hydroxide, and you have CO2, and those two get together. They create a new compound of potassium carbonate. They also give off a little bit of water vapor as well that is blown back into the flue gas. But that latent heat that's in there is enough that it's not a concern for the venting. For those of you in the HVAC market that get worried about moisture. So the whole process generally takes around 10 to 14 days, once again, depending on how often that heating appliance is running. And then we go in with our technicians, we vacuum it out. We put it in 5-gallon pails. Those 5-gallon pails are then brought back for central distribution. They're dumped into a larger container, and then that larger container is then shipped off to industry to be applied to the soap and detergent industry.
Very cool. Very cool. We've got a question from Maya. For those looking to measurably reduce their GHG emissions, what effect would installing a Carbonix unit, can that help with reducing emissions?
Great question. Thanks, Maya. So there's two fronts to that. The one front is the fact that we're offsetting the amount of natural gas that's needed through heat recovery. So if a tank doesn't have to work as hard or burn as much natural gas, to meet the same energy need as it did before, that's good. We're obviously saving a significant amount of greenhouse gas emissions. The primary focus for our end is the utilization of that carbon, and that's the capture process. So we obviously directly and indirectly reduce the carbon emissions from the appliance that we're attached to. And the amount of GHGs can vary. We've seen some higher indications, but our average that we're sort of focused in right now is a 20% drop in overall GHG intensities in the mechanical room. Once again, depending on the configuration of that mechanical room.
20% is massive. If you look at all of the buildings that just so happen to need heat in Canada, I would imagine that that would stack up to a pretty measurable chunk of emissions being reduced if there was a full deployment of this technology in every commercial building. Could you maybe talk about what that would look like and what our total addressable market would be?
Sure. I mean, it's the heating industry is massive, and the amount of stuff that the world consumes is massive. But in terms of numbers, Canada's about roughly 25% of Canada's GHG footprint comes from creating comfort. It comes from keeping our homes warm or places of work warm, heating water, all of these things that require the use of natural gas to create heat. So yeah, roughly 25%, and it's I believe about 12% in the US. So that sounds like it's less, but when you deal with a significantly larger population density, 12% is actually more than what Canada produces in terms of GHG. So smaller percentage, but we can have a bigger impact in overall capture ratios.
Very cool. So if I'm hearing you right, 20% of 25% of our emissions could be reduced at full deployment?
Correct.
See, that would move the needle.
That would definitely move the needle. Yeah. Yeah. And we can do it while washing our hands, which is obviously a very important thing that we all want to be doing a lot of right now.
So, yeah, absolutely.
So it ties in nicely.
We have another question asking, how did you come up with this cool, sleek design?
That's a great question. Thanks, Nicholas. In order to engage people in the conversation surrounding energy efficiency and carbon capture, you have to make it engaging. You have to make it tangible. You have to make it attractive. So we took a look at consumer electronics and borrowed some of the design aesthetics from what was out on the market and applied it to this technology. We didn't want to create what most manufacturers do is just, they create a square box. And the mindset of that is, well, it's in a mechanical room. Who cares what it looks like? Who goes in there, right? Plumbers go in there and they don't care. I would counter that and bring up the fact that at one point in time, it did matter. If you look at some of the older boilers, and I often reference a boiler that's installed at a church in downtown Calgary. This boiler was installed in 1923. And I don't know if any of you have seen the pictures that I've circulated, but there's floral inlay in the legs of this boiler, and there's rounded edges, and there's aesthetic qualities that serve no purpose to the utility of the device, but they put that in there. And they put that in there because they cared, right? They cared about the work that they did. And then somewhere around late 1960s into the 70s, we stopped caring. Somebody just said, it's costing us money. Let's just get rid of that design quality and just build a plain ordinary box. So we want to kind of bring that back in to engage people, because when you walk into a mechanical room, the very first thing you see is our technology, and that's by design, because then that opens the door to the conversation around energy literacy. It opens the door to its carbon emissions, efficiencies in terms of boiler and heating equipment management. So to answer your question, it's largely it's borrowed ideas from other consumer electronics manufacturers.
Very cool. So you're the Apple of appliances in furnace rooms?
Can I say that? I don't know if I can say that. Can I make?
No. But you can't say that. You'll get a very mean email.
Yeah. Cease and desist. Yeah. No, that's we really appreciated how people are engaged with their game the game stations, their Xbox and the PlayStations, and their refrigerators and their all of the devices out there. And there's a very sort of specific design quality to all of these devices, and none of that exists in the HVAC industry. Not that I've seen. There's some that are coming out with newer, sleeker designs. A.O. Smith has got some new condensing hot water tanks that look pretty cool, but largely they're just boxes, square stainless steel boxes.
So the one thing that I love about this technology is that it does not rely on some subsidies or carbon credits or something that with a stroke of a pen could go away tomorrow and your business model is upside down. I love that it is old-fashioned, old-school value, reducing costs, and actually generating revenue. Could you talk about the profit-sharing piece to this puzzle?
Sure. Right after we developed the technology, or right near the end of the development of the technology, we realized that we wanted to make sure that any business model we had that would allow us to deploy this technology wasn't requiring that subsidy. I refer to the Ontario wind industry often, and that, at the moment the subsidies dried up, a lot of companies went belly up, and we didn't want that. So we had to find a way to engage the customer where they had a quick return on their investment, and engage them beyond the return on their investment. So what better way to do that than through profit sharing, where they're winning and gaining by capturing carbon, a waste stream. They're just venting it to atmosphere. It's of no purpose to them. It's a waste stream. So we thought, well, let's turn that waste stream into a product we can then put out into the market. It's cost comparable or even less in some cases. And then we profit share with the customers so they can see the value. And then even after the ROI is made, they're still having an ongoing revenue stream that's being generated from their mechanical room. It's like a mini, mining operation where we're mining. Urban mining, I think, was a term that we came up with a couple of years ago. So
urban potash mining. I love it.
Urban potash mining. Yeah, exactly.
Very cool. Well, we've got another question here. Can condensing boilers and HWT flues go through this unit? And that's from Vigor as well.
Thank you. Yeah, that is another really good question. One of the issues that we've actually had to face is that moisture content. So the technology does work in a condensing application, but it makes the collection of that byproduct challenging for us. Our goal is to keep that relationship with our mechanical contractors as simple as possible. So, they're in and out of these rooms in a half hour or less. And with future designs we have coming down the pipeline, we're going to get that down to even 5 or 10 minutes to do a changeout collection run. So to answer your question, it will work. However, we avoid cases where we're putting this on category 3, category 4 condensing and fan-induced appliances because of the risk of condensing. Now, the spin-off of that is that in the retrofit market, quite often people are installing these high-efficiency boilers, expecting them to condense and to be really efficient. They're buying a 98% efficient boiler that will never see 98% because of the configuration of which it's been installed. You can't put a brand new engine in a really old car and expect it to behave exactly the same as a brand new car. So there's some performance issues that are not being addressed when you go out and buy a high efficiency boiler. So in those cases, those condensing boilers don't condense, therefore they don't produce any moisture. Therefore, it's actually something that we can do. We're actually just starting now to go into those high efficiency appliances, the condensing and non-condensing fan induced, which is known as category 3 or category 4 appliances. It's early stage. We've got some little kinks to work out, but in time we'll be able to get into those boilers as well.
Beautiful. We've got another question here from James. Have you had any success with installation on natural gas steam generation boilers in commercial or institutional buildings, something that creates process steam or humidification steam for research facilities?
Yeah, so we're dealing predominantly with the flue gas of the appliance, and we are focused largely on the commercial heating space. So we're limited in terms of like in the industrial place, we could scale these unit up and make it work for those applications, but they're just right now they're set outside of our scope of focus. So to answer your question, we haven't had any success because we haven't really approached any of those applications. We're really just focused on that scale of boiler between 240,000 BTUs and 1.5 million BTUs. So your schools, your smaller hospitals, hotel chains,
Rec
malls,
centers.
places like that. Yeah, rec centers, exactly. That's kind of where we're predominantly focused.
Very cool. And do you see a future in which you have multiple sizes? Because right now it's a one size fits all.
Absolutely. Yeah. And as I mentioned earlier, there's no reason why we can't make larger units for larger industrial applications or smaller units for circling back to the single detached residential market space. We have every intention of exploring that, of scaling our technology up and down to whatever suits the customer's needs. So we should remind people our company mandate is to reduce in its entirety the carbon emissions coming from this industry. So, we're hovering around that 20%. Our goal is to get to 100%. Now, saying that doesn't necessarily mean that this is the technology we're going to be using or the vehicle we're going to be using to get to that 100%. But our focus is to get to 100% by whatever means necessary. And this is just the start. So when we talk about larger applications or we start talking about smaller applications, it doesn't necessarily apply itself to our current state of our technology, but it is something that is in our mandate to pursue.
Very cool. Very cool. Excellent. So would you be able to shed a little bit more light on where you're looking right now? Like what are the target markets that you'd like to get into? Where are the good fits? What's the low hanging fruit? And where is this best allocated?
So our success so far has come at the hands of some great organizations like ATCO Gas, like FortisBC and CenterPoint and Enbridge, and a lot of the gas utilities are approaching us, and they're great. They're great avenues for us to pursue because they provide access to clients that we wouldn't really have access to. Imagine me showing up at the door of the head office of Lush, for example, or some other company. They're going to show me the door, or they're going to give me we'll get back to you as quickly as we can. I really wouldn't have the access to that. So thanks to the connections that these utility companies have, allow us to move forward with having a really broad impact from commercial property owners to malls, retailers, hotel chains, cosmetic and soap manufacturers. So that's really our primary focus right now, is to continue to develop those relationships with the gas utility firms so that we can have a positive impact on their industry and the heating industry and the soap and detergent industry, because we really are able to differentiate ourselves from anything else there on the market.
Beautiful. Well, there's nothing more enjoyable than a helping hand, especially when you're a startup. Is there any other special shout outs of people that have helped you get to where you are? Anyone that you'd like to say thanks to that's been a pivotal part of your journey?
Yeah, there's all sorts of people that I would love to say thank you to. I'd love to mention the Southern Alberta Institute of Technology for their continued support in helping us develop our IoT applications and better understand the chemical sort of equation. Shout out to the Alberta Municipal Affairs for their ongoing help. City Manny, you've been fantastic. We're looking forward to working with you. Technical Safety BC, Ryan Milligan, you've been fantastic. Great help, and looking forward to continue working with you and the great folks at FortisBC, Ramsey Cook, Pete Kofkin, and of course, the folks at RDH who are doing the independent energy auditing. Also like to thank the University of British Columbia for their involvement with ATCO Gas's Whitehorn station, for their continuing monitoring to help us tell a better story. Folks down at CenterPoint, Ethan Warner, Nicole Murphy, Rush Wagner, all of those folks. Someone on the line here, Nicholas, um, you know who I'm talking about here. I don't want to go too far down the thank yous there because I'm not sure of what I can say just yet, but thank you very much. And I also want to thank the folks out in Enbridge who continue to try and find ways to get our projects out into Ontario. The National Research Council, who is always there, the Canadian Trade Commissioner's Office, both foreign and abroad. Foreign and domestic, rather, sorry, that have been hugely helpful. I even want to shout out to South Burnaby Pictures. You'll notice on some of our postings, we've got some new renderings of our technology. They've been great in helping us produce better images of our technology for our marketing campaigns. And also want to thank the folks at Energous, Mick Canfey, Maya Hassa. You guys have been fantastic in providing guidance for us during this transitional phase for us. And Tundra Process Solutions, Eric, you are amazing as always. You are a rock star. Yeah, so I think that's, I'm sure there's many other people that I'm forgetting. I feel like Academy Awards, like there's always that one person that I'm forgetting.
Of course.
Thank my wife, thank my family. I'd like to thank the Academy.
Right. So as we start to draw to a close, I actually heard a rumor that there is a bit of a soap shortage going on right now, given the scramble for hand sanitizers. And a lot of folks, given that they're now washing their hands 10 times a day versus never, there's a bit of a shortage going on. Luckily, we make soap.
Weird, right? I know a guy.
Yes. And what's
I'll hook people up.
Definitely. Well, that's what's so great is that not only it's not just any soap, it's soap made from recycled carbon. And when you're talking about the circular economy, and what an amazing story. Could you maybe talk a little bit about how the soap is made and how people can get it?
Sure. So there's a couple of different avenues that you can take. Currently, we have some new e-commerce channels set up through our website. If you're interested in any of our products, be it bar soap, body bars, or our liquid products, you can buy them directly through our website. If you have an Amory supply in your neighborhood, our liquid hand soap is sold in stores across the country from Ontario to BC. Check out your local Amory's if you still have access to them. You can buy it online as well. And I think that's it. We've got some other avenues that we're looking at. We just got set up with a large multinational retailer. So you're going to see a lot more avenues and availability for our products. But for all of you online, if you'd like, just check out our fancy new website. We're pretty proud of that.
Very cool. When we're looking at the different products that you're able to make from the produced potassium bicarbonate, what other products are you dreaming up? I know I've seen some surface cleaners. I think you had some car wash detergent. You guys are busy in the lab dreaming up really cool products for this recycled.
All sorts of things. Yeah. So currently we have laundry detergent that's good for top loading as well as HE washing machines. We have a car wash detergent, which we have going through a couple of car dealerships here in Calgary, and they love the product. The price point is actually I think we were a few points less than what they were currently buying. Of course, our body bars we're providing thanks to our friends at All Things Jill. She does a great job of creating these organic body bars with our potassium carbonate. But it even goes beyond the soap and detergent industry. And there's possibilities for us to move into things like ceramics, glass manufacturing. There's opportunities for us to work with fertilizers. Potassium carbonate is used in wine making as a fertilizer. So, maybe CleanO2 wine, we can have a nice Chardonnay. Yeah, there's all sorts of different venues. The pharmaceutical companies use it. It's like we often call the potassium carbonate sort of the Swiss Army knife of chemicals, just because it is used in such a broad array of applications.
Very cool. And one thing that blew my mind, I mean, I've never, before meeting you and learning about all this, I had never even heard of potassium carbonate. And now it's just like when you're about to buy a new car and then all of a sudden you see the car everywhere. So now I'm seeing potassium carbonate everywhere. Sure enough, anytime I'm reading an ingredients list, I'm like, what is it doing in my toothpaste?
Yeah, it's in ice cream. Why is it in ice cream?
It's in my toothpaste. It's in how big is the potassium, the market for potassium carbonate?
Yeah, going off of my memory, I believe the market is somewhere in the range of $200 billion a year. I think we go through 30 or 40 billion metric tons per year of potassium carbonate. Most of that goes into the agricultural industry. About 25% of that goes into the soap and detergent industry, and then there's a bunch of other smaller industries that tap into that. So it's really quite massive. You know, something kind of interesting to bear in mind. We don't necessarily even need to just entertain potassium carbonate production. There are other hydroxides that can be converted into carbonates as well. So we could do calcium carbonate production. We could do, we started off doing sodium carbonate production, but you know, the markets are pretty well saturated now. So there are other avenues for us to be able to produce chemicals for other industries as well.
So there's no risk of saturating the market in terms of deploying all these technologies across the world. It's a big market.
It really is. I mean, just think about the soap market. Just think about the soap market. I think for a moment of where soaps and detergents are used, and it really is truly massive. Taking out the pandemic out of the equation and the inflated amount of use of soap and detergents, just look around you. Look at the car wash. Look at the car wash stations. Look at the laundry service industry, and not just your residential. We're talking commercial laundry. Look at the hotel chains go through a tremendous amount of soap and detergent. Look at the malls. Look at all the public washrooms. You know, as I said earlier, if you look at a high-rise building, every floor has to have at least 2 bathrooms. And that's a lot of floors, and there's a lot of cities out there. So just in the soap and detergent industry alone, it's massive. So I think we've got a long way to go before we even need to worry about any type of market saturation. And frankly, by the time we're even close to that, I suspect we'll probably have some other technologies that we're currently developing that will perhaps even reduce the amount of potash that we're producing because we've moved into producing something else or done something else that's reduced the amount of carbon emissions coming from this industry.
Beautiful. Beautiful. So for everyone on this webinar, you know, if there are folks out there that want to help, how can they get in touch? How can they let that help become a reality?
Sure. The best channel to get a hold of any of us is just to dial into soap@cleano2.ca. Send us any of your questions, comments, concerns, any of your requests. We're always happy to work with. We love working with schools. We love community outreach. We love getting involved with our local community and our communities abroad. We want to help in this time, and we want to be able to provide value to anybody that would like to be a part of our story. We want to make you part of our story. So soap@cleano2.ca, our website, any of our social media channels are monitored fairly regularly. So there's a number of ways that you can get a hold of any one of us.
Great. We've got one last question that got snuck in here. What happens when the soap goes into the municipal water treatment system?
I wish Kathy was here to answer that one, but so that's a question that some of you were maybe aware, but earlier last year, or maybe it was around the middle of last year, we had a big news blurb that came out about us through CBC and the National Post, and that was the most commonly asked question, is that people had the assumption that the moment you use our soap, the CO2 is vented to atmosphere. So regardless of where you put it, whether it's going down the drain into the water treatment facility or whether you're just washing with your hands, the CO2 stays sequestered. And the great analogy that we can use, our engineer Warren Brook came up with this, is that imagine, if you will, the chlorine in the ocean, right? The sodium chloride that's diluted in the water. Now, when the ocean water evaporates, we don't get a bunch of chlorine gas that evaporates along with it, right? It stays in its mineralized form. That's how we get salt beds down in Nevada. So the carbon stays sequestered. You have to either burn it or heavily acidize it in order to be able to release the carbon. And if you're burning, you got bigger issues. You got too much time on your hands. So yeah, it's really difficult to release that CO2 once it's been embodied in the soap, or in the potash rather.
Beautiful. Awesome. Well, as we're wrapping up, we got about 2 minutes left. I want to thank everybody for joining us on this session. And as a special treatment for everyone who joined this session today, if you type in your name and your mailing address, Tundra Process Solutions will mail you a free bar of CleanO2 recycled soap. So just put your name, mailing address. We will mail you a free bar.
That's great. Now, on that note, it looks like I'm buying you lunch there, Eric.
Yes. Still, this great turnout. Really appreciate everyone. Jason, any closing remarks from you?
No, everybody just needs to stay safe, stay isolated, wash your hands lots, support your local small businesses, get involved where you can, stay safe. Just remember to stay safe and wash your hands, wash them lots.
Beautiful. Excellent. Well, thank you, everyone. Again, type in your name and address. We will hook you up, and everybody have a great day. Stay safe, stay healthy, and we will see you again next time.
Thank you so much. Take care, everybody.
All right. Take care.